All right, the next thing we want to look at is how to rationalize a denominator. And so this is part of what I called, or what people call, the simplest radical form. And basically the thought is, if you have a fraction and you have a radical in the denominator, the simplest radical form says that you cannot have a radical in the denominator, that you should change it so that it's just a whole number, and that is just the rules to becoming to take something into simplest radical form. So if I said root of 2/15 here, you might be thinking, well, what could you do with it, right? You could use the quotient property to say this is root 2 divided by root 15. And if you have a fraction like this, the problem is, and it's not really a problem, but it doesn't fit the definition of this simplest form, is that in the bottom, or on the bottom, you have a square root on the bottom of this fraction. And if you want to get rid of that, we can do that. All we need to do is just multiply the bottom by something such that it, gets rid of the square root. The easiest thing to do here is just to multiply it by itself with a square root. So if I multiply the bottom by basically itself, right, the square root of 15 times the square root of 15, then I would get the square root of 15 squared, or 225 you could write it as. Now if I do that to the bottom, I'm going to do that to the top. So the top would become the square root of 30. Now because of the way that we did this, this square root of 227 right here, that's a perfect square, right? That's going to become just normal 15, just the whole number 15. Because when you take a square root and you multiply it by the exact same thing, you get just whatever's the radicand. In this case, it's just 15. So that's a pattern that always happens and always works. On the top, we get root 30. So this problem right here, simplest form would be the square root of 30 divided by 15. Important to realize here that this value here, whatever it is in your calculator, whatever the approximate value is the same thing as this, which is the same thing as this. All we're doing is switching the form of this value. We're switching the way that we write it to fit this definition here of simplest radical form. You can see that we don't have a radical on the bottom anymore, and therefore it fits that definition. So let's try another one. If I have the square root of 6 over 63, I would use the quotient property to say this is root 6 over 63. That's another way to write this problem. And we could do one of two things. The first is to simply go ahead and rationalize this denominator right away, like we did with the top one, by multiplying this by just the same number, root 63 on the bottom, and multiply by root 63 on the top. And you can go ahead and calculate that. I know the bottom will just become normal 63. The top would become 63 times 6, which is 378, or root 378. And so now you might be thinking, all right, this is good. I have the bottom is not a radical, and so this must be in simplest form. However, if this square root up here can be reduced any further, you need to do that if you're going to put it into simplest radical form. So 378, you want to think about, all right, in 378, is there a perfect square inside of 378, just like we did the other problems before this? So, yeah, so 378, if you're just thinking about that, here, let's do it down here. Square root of 378. I know, just by fiddling with my calculator a little bit, I know that 9 goes into it. So I know that 9 times 42 is equal to 378. So therefore, that radical is going to be 3 root 42, and that would simplify just the 378. 42 can't be simplified anymore with that square root, so this would be kind of it. So now if I go back to my problem that I was working with right here, this would become 3 root 42 over 63. And now what we could do, so this is even better, this is more simplified, but now if you take a look at these whole numbers, right, we have a 3 on the top and we have a 63 on the bottom. Now if we can reduce this 3 divided by 63 here, okay, not going to touch the root 42, just thinking about these whole numbers, can I reduce 3 over 63? And you can, right? You can divide 3 and 63 by 3. That fraction, that red fraction, will become 1 over 21. So really, to finish this problem, this would become root 42 over 21, because this 3 over 63 would become 1 over 21, and therefore this would be our answer there. So what we're trying to do here is get you used to taking a radical, using that product and quotient property, and rewriting the problem in various ways, equivalent ways, to reduce the problem, or get it into simplest radical form of what we're talking about here. So that would be simplest radical form for this problem. Let's see what else we have.